and welcome everybody. So today I'm going to do a presentation for my instrumentation project which is automatic source dispenser. This presentation is a continuation from the previous presentation that I did before, but that one is for transducer, but this time is for signal conditioning. Before we go further to the selection of signal conditioning, I would like to state the problem statement that we identified from the project. So the first problem that we identified was noise vulnerability, and the second one is signal instability. This kind of problem happened because the raw output signal from the proximity distance sensor is highly susceptible to environment background noise and physical variations. Factors such as stray wave reflections, ambient light variations such as the reflection from the container itself and structural vibration from the pump cause rapid fluctuation which lead to high frequency ripple in the signal voltage. The impact of the problem if we do not encounter this kind of problem is in terms of voltage signal range, the sensor will transmit unstable timing pulses or rapid voltage spikes to the controller. The second one, it will give a false triggering. Without conditioning, this erratic signal fluctuation will misguide the controller, leading to false triggering where the relay module activates the source pump unexpectedly when no container is actually present. That's all from me.
Okay, now let's talk about why we need this signal conditioning and how it protects our system. First, we use the Arduino that built in analog to digital converter. The raw signal from the sensor is an analog voltage that constantly fluctuates. The Arduino converts this voltage into the clean digital number between 0 to 1023. This is crucial because it allows our microcontroller to read the sensor data accurate without losing any signal quality. Second, to prevent the pump from randomly splashing or triggering by accident due to electrical interference, we added digital moving average filter that directly into the code. Put simply, the code constantly takes the last 10 reading from the sensor and calculate their mathematically average. Because of this, if there any happen or sudden like random voltage spike, the system completely ignore it. The source pump will only trigger when the container is steadily held under the sensor. This keeps the dispenser safe and prevents for any messy source spills. Next, let's look at how the circuit actually works using our system block diagram. The system is broken down into the three main parts. First, we have the transducer, the signal conditioning, which is Arduino Uno, and the lastly is a relay module. For the transducer, which is a proximity sensor, the job itself to detect if a cup or container is placed under the dispenser. However, the raw signal coming straight out of the sensor is usually quite noisy and unstable. To fix that matter, the signal is sent to our second section, which is the Arduino Uno. This actually acts as our signal conditioning, where it cleans up the data using a 10-bit ADC and a software moving average filter. Once the signal is clean and stable, the Arduino finally send a command to our test section, which is the relay module. That switch on the 5 voltage DC source.
Okay, this slide presents the expected signal analysis and filtering performance by comparing the sensor signal before and after signal conditioning. On the left side is the unfiltered signal contains significant noise and unstable voltage fluctuation caused by environmental interference. As a result, the relay may switch on and off unpredictably, but which can lead to false triggering and unreliable system performance. On the right side, after applying a digital moving average filter, the noise is greatly reduced and the signal becomes much smoother and more stable. This produces a clear step response when a container is detected, allowing the system to make more accurate decisions. For overall, this signal conditioning method improves the reliability of the sensor, prevent false activation of the relay, and ensure consistent and accurate source dispenser. Thank you.